negative. They can't be not negative. That's why we call them non-negativity. So here it is. This is the model right there. It's not just one equation, it's a lot of them. Okay, that's the whole point. That's the new part of what we're doing here. And then next week, it's going to be just more, but it's the same process. So step one, set up and define your variables. Step two, create your objective function. Step three, create your constraints. Okay, and that's all really a part of the formulation step, turning the word problem into a model. Now we're ready for the solve step. We want to take this model and we want to find the answer. What is the maximum profit that they can make? Given all this information, what is the maximum profit? So the way that we're going to do that is we're going to start off with the constraints here. We're going to graph the constraints to get what we call the feasible region. Then we're going to use the profit function here to create level lines to tell us where in that feasible region the solution lies. And then once we know where it lies, we can then sort of pinpoint it a little easier. So let's graph. Let's take the first one first, the carpentry time, and here we go. You have to remember your skills of graphing, your tools of graphing. So what do we do? Well, recall, and it may not be on top of your mind, but remember the process for graphing inequalities. What was that? It was a two-step process. The first thing you had to do is you first had to graph the equal sign part of it. Why? Because what does the equal sign represent? The equal sign part of it. Okay, so remember it's less than or equal to. So we're taking the equal to part of it. The equal to part of it gets us the barrier, the line. And then the less than part tells us whether we shade above or below the line. So that's the two steps. Graph the line to find the barrier, then graph the inequality shading above or below that line. That's all you do. So let's do this. I'm going to do what's called the intercept method. And basically what you do is you use 0. Okay, so let's take 3t plus 4c, and we're doing the equals because we need to graph the line. And what you do is you should say, let's start off with saying t is equal to 0. What is c? When t is equal to 0, what is c? So take t and replace 0 with it, and then solve for c. So we get c is equal to 600. Why is that a big deal? Is because then we go to graph that point. It creates an ordered pair. When t is 0, c is 600. Okay, so we have the t-axis here is the horizontal axis, and we have the c is the vertical axis. Graphing creates an ordered pair. So when t is 0, we put a dot on 600 on the c axis. On c, put a dot for 600. That's what we do. Rinse and repeat. This time, though, what is t when c is 0? So basically move 0 into the other variable. Okay, now this time we're going to solve for t. And so we get t is equal to 800. Okay, so this says that when t is 0, when c is 0, t is 800. So go to the t-axis and put a dot on 800. And now we've got two dots. You connect the line. You connect the dots with the line. There's the barrier. There's the line. That's all you need to do. Intercept method. Now what we need to do is we need to shade. Either we're going to shade above the line or we're going to shade below the line. Which one do we do? Well, back in algebra, you had to go through this whole process. And that's what this slide shows you here is you had to do a test point to see which one works out. Shortcut time. You don't have to do that because we're doing this with the less than equal, the less than. Less than means down and to the left. So that's what we shade because it's a less than. That's one of the reasons why we want our number on the right-hand side because it helps with the shading and all that stuff. Okay. So that's the process. We're going to use the intercept method. Okay. So let's then take our other equation, our other one, t 2t plus 1c less than equal to 1,000. Okay. 1,000. So let's do the intercept method again. T is 0. What is c? Okay. That. So 2t with t is 0 plus 1c is equal to 1,000. Well, then that just means that C is equal to 1,000, okay? And this time flip the zero. What is T when C is 0? Okay, so 2T, so this becomes 2T equals 1,000? Typos all over the place. So that means T is equal to 500. Okay, so let's graph. With me, where, oh, there it is, there it is. Sorry. And let me do this. Okay, so the first one here says when T is 0, put a dot on C is 1,000. And this one says put a dot on C is 500. And now we're going to connect the dots. There we go. And then because it is a less than symbol, what do? We shade down and to the left, down and to the left. And so we shade, well, let me change this. We shade this region right here. Okay, there it is. Now, if you notice, and I'm sure you do, there's a region right here, I'm going to try to do it in pink, that is overlap. That's the section we keep. Everything else we discard. We discard this up here, and we discard this part over here. Just keep the overlap region. Okay, so here's what it looks like when we do that. Just keep the overlap region. Now we have two more constraints that we need to do. Remember, it's C less than equal to 450. How do we graph that? How do we graph the line? You can't use the intercept method. So what you have to recall from your days of algebra is that when you have one variable, it either makes a horizontal or a vertical line. How do you know which one? I don't know, but here's how you do it. So we're dealing with C variable. So go to the C axis and find the value of 450. Okay, so here it is. So here's 450. And what you do is you draw a line perpendicular to that. So because it's vertical, perpendicular means it goes out horizontal. Oh, that's how I know. That's how I know. And we're going to shade the section below the line, but we're only going to keep the portion of this region right here in orange that lies below the line. That's what we're going to keep. Okay, so this little triangle up here is going to get discarded. All right, the next one says what? Do this. So the other one was T greater than 100. Okay, so it says go to the T axis, find the value of 100. Go to the T axis, find the value of 100. Here it is, put a dot on it, and then draw a line perpendicular. Okay, well, this is horizontal, so perpendicular would be that. And then do your shading. And because it's greater than, shading means shade to the right. Shade to the right. Greater than is right. But really, we're just keeping this portion of the orange. That's what we want. So this is what we're going to keep, is just that portion shaded in red. So what does it look like? Here's what it looks like. This is called the feasible region. The feasible region. This is the set of points, the region that satisfies all the constraints simultaneously at the same time. Okay, why do we want to do it? Well, if you take notice here, notice these lines, they intersect, okay? And they create these little corner points as a result. They create these corner points right here. And here there's 5 of them, the intersection of all the constraints. Your solution is going to be one of those 5 points. The solution is going to be one of those 5 points. That's why you draw the feasible region, is to know where your corner points are. So how are we going to determine which one is the solution? We're going to do what we call level lines. Essentially, what we're going to do is we're going to take the profit line, take different values of profit, and see what line that gives us. Okay, so here's an example. Remember what the profit function is. Profit, P, is equal to 7T plus 5C. Okay, so what you do is you pick a value of profit. What value? Doesn't matter. 2100, pull it out of a hat. And so we're graphing the line 2100 is 7T plus 5C. We don't really care what number you pick, 2100, 21 million, it doesn't matter. You just want to see what it does. Okay. Then pick a new value of profit. Change that 2100 to 2800. Okay. 2800, 7T plus 5C. What does that graph look like? Okay. So it looks like this line. What's the whole point? What's the whole point? Well, as profit increases, the level lines start to propagate outwards. This is what it looks like. And so what you want to do is you want to find what is the outermost corner point, or another way of saying it, what is the last corner point that is hit, okay, by a level line, okay? And we see that it is this one right here. Oops. We see that it is this one right here. That is what we call the optimal corner point solution. Optimal corner point solution. Optimal corner point. Optimal meaning optimization. This is where the maximum profit occurs. Okay, this is the last point in the feasible region. So how does that help us? Well, because we have to remember, let's go back a screen. This corner point, these corner points are created by the intersection of constraints. So what we do is we take those two lines for those constraints and see what see where they intersect. And what that means then is we take the equations, we use the equal signs because that's the equation of the line, that's the barrier. So we have two equations, two unknowns. Uh-oh, more algebra. This is solving systems of equations. And so you can use the substitution method, the elimination method, whatever you want to do. I'm going to use the elimination method. I have a video in the announcement if you want to review that. But basically, I'm going to hone in on the C. I could have honed in on the T. It's certainly fine, but I just said I want to get rid of C. So I ask myself, what value will both the 1 and the 4 in front of the C, what's the first value that they both go into? And the first value is 4. So I already have a 4 here, so I need to get a 4 here. What number do I have to multiply the 1 by to get a 4? I have to multiply by 4. But you got to do it to both sides. So take that 4, multiply it to both sides of the equal sign. So 4 times 2t is 8t. 4 times 1c is 4c. And then 4 times 1,000 is 4,000. And now we subtract. So 3t minus 8t is negative 5t. 4c minus 4c goes away. Eliminate it. That was the point. That's why we did that. And then 2,400 minus 4,000 is negative 1,600. Solve for t, divide both sides by negative 5. And when we do that, we get t is 320. Remember what t is, the number of tables. Oh, that's the number of tables we're going to make. 320 tables in order to maximize our profit. Well, how many chairs are we going to do? Well, now that we have t, let me do this, and let me do this. Now that we have t, go back to one of your original equations. 2t, plug in the value of t. So that's 2 times 320. I'm gonna type here in just a second because my handwriting is terrible. 1, 2, 3. And then solve for t. So this is 640. 1c is 1,000. Subtract 640 from both sides, and we get 1c is, I'm going to cheat and see, look at the answer. There it is. That's how we get 360. Plug the value 320 in for t, and then solve for c. So now we know to maximize our profit, we need to make 320 tables and 360 chairs. What is that max profit? Well, we go to the next slide, take our profit function, plug in the values of t and c that we just found, do the math, there it is. That's the maximum profit we can make. And I went over a little bit, sorry about that. So that's what you're doing this week. It seems like a long process, and candidly, it kind of is. Next week, we're going to see how we can shorten that process. We're going to use technology to help us out, and it's going to make the job a whole lot easier. It's going to have its own headache, but it's going to be a little better, in my opinion. Okay, so this is it. We're going to do this process again next week, but just remember, set up your variable, set up your objective function, set up your constraints. Then to solve it, graph the constraints to get the feasible region, see where use your level lines to see what the furthest corner point out, and then get those lines and use system of equations to solve and find that point. And that's it. So good working with you. Hope you have a great rest of your day. I'll see everybody in the discussion board. But if you have any questions in the meantime, please don't hesitate to contact me. I'll be glad to help however I can. Hope you have a good rest of your day and a great week. Very welcome. Very welcome.
Please, I have a question.
Uh-huh.
I have a question, sir.
Yeah, go for it.
Um, why you were talking about the variables? Is the the equal sign the same um as the less than or equal to sign?
Mhm. Up here. Is that what you're talking about?
Hello, hello, sir.
Yeah. Yeah, can you hear me?
Yeah, I can hear you.
Yeah, so yeah, what's your question? Is this the slide you're talking about? Sorry.
Yes, sir. The less than equal to sign variables is the same as equal to sign.
No. Less than or equal to means you can be up to that or any value below it. Equal means you can only be that value. So if I say equal, that means it can only be 2,400. That's it. We got to spend all 2,400 hours of carpentry time. Here, this says we can spend up to that or any amount less. So maybe we only spend 1 month 2,000 hours. 2,000 hours. That's what available means. It's there to spend, but you don't have to spend it all.
Okay, thank you.
Sure, sure. As you work through some of your questions too, because sometimes some of the questions, at least I find when I do the work, the question sort of comes from that left. I'm not articulating it well, so I apologize. But yeah, yeah, don't hesitate to get me involved again.
All right, thank you.
Okay, yeah, for those of you still hanging out, Jason asked a question. If we missed the live chat, do we submit a summary? In our class, no, you don't have to do that. And the reason is because we don't in the 400 level class, you don't get points for attendance or the summary. That's not a feature available in our class. I know what you're talking about. I think I remember that in college algebra, they would do that. But no, if you miss it, the recording's there available. I encourage you to watch it, but you do not have to write the summary. Save your time and work on other things. I see you, Devontae. Yeah, I hear you.
I like my extra credit.
Uh-huh. Uh-huh. Yeah, it'd be a good feature in this class. I've advocated for years, but the reason I haven't done it is because of the level of class, the 400 level. By this point in your education, you're motivated enough you're motivated now uh, to come to class. So they don't need to dangle that carrot in front of you anymore. That's the idea behind it. But I think for our class, it would still be helpful. Anybody else have any questions? Yeah, LaShonda, good point. Yeah, so attending the live chats, not a requirement. Here, if you want to attend, if you would prefer to watch the recordings, it's there available to watch at your convenience. That's a good question. I forgot to mention that. All right. Well, I'm going to go ahead and wrap this up. I do hope you have a great rest of your day, and as always, let me know if you have any questions. I'll be glad to help out. Hope you have a good one. I agree, LaShonda. I think the live chats, I agree. I think the live chats are helpful. Even if you can't make the live, watch the recording because I think it's going to be helpful. It's going to help address a lot of the questions. And not to toot my own horn, but I do think that it's easier to work through the material in IntelliPath when you've watched the live chats. May not be easy, but it's easier. So anyway, okay. All right. Well, hope you have a good rest of your day.